Okay, here we're going to discuss a little bit of the increase in entropy principle. And to do this, we'll start by defining what we call an isolated system. And what an isolated system is in a large system that contains the system plus a small portion of the surroundings. And you make it big enough so that any energy mass transfers are within this enlarged boundary. Okay, so we're taking a little bit of the surroundings as well, so it's considered an isolated system where all of those transfers are occurring within the boundary. When that occurs, basically Q and W go to zero, right? So that basically means the change in energy has to equal zero. Okay, so this is both not both, but the sum of the change in energy in the system plus the change in energy of the surroundings equals zero. So the total change in energy of the entire system, both systems and surroundings, have to sum together to equal zero. So the system could be one thing, but that means the surroundings has to equal negative that. Okay? We do the same thing with the second law equation. Okay? Again, heat transfer is now within the system. Okay? So there is no heat transfer to the expanded surroundings, right? So that change in entropy, delta S, okay, is the change in entropy of the system plus the surroundings. Okay, again, Q goes to zero. So that total change in entropy has to equal sigma, right, from that second law equation. And that is both the change in energy of the system plus the change in energy of the enlarged surroundings has to equal that sigma, that entropy production. And because of this, okay, processes always have to occur in such a direction that the total entropy increases, right? Sigma has to be bigger than zero, okay? So expanding this to put the surroundings inside with the systems, have this large system, that total change in entropy of both the system and the surroundings added together has to equal a positive number, has to equal sigma, which is a positive number. Therefore, entropy is always increasing, and we can define the direction that things move such that the total entropy in the enlarged system has an increase in entropy.